P6 and 7 is going to be a review of rational expressions. Now recall that a rational number is a fraction in which the numerator and denominator are both integers. So a rational expression in this case is also going to be a fraction, but in this case you're going to have polynomials in the numerator and the denominator. So when we're looking at rational expressions, we do have to concern ourselves with the domain. So that next part in your notes, the first step in simplifying a rational expression is to determine the domain of the function, which is the set of all possible values of variables. Now we've talked about finding domain before, and one of the things we looked at is if there were fractions, right? Because we know that the denominator cannot be equal to 0 because division by 0 is called undefined. So the denominator can't be equal to 0 because division by 0 is undefined. So before, our fractions were fairly straightforward, but and sometimes our denominators aren't going to be quite as easy. So we have to solve for 0, which is one reason why we talk about finding 0 so much, because those are the skills that you will need to define your domain. So let's look at a couple examples and kind of review for what we did. So 1a, let's say we have the rational expression 7 over x plus 5. So remember, a constant is a polynomial because it doesn't have any things that say it's not. It's just that constant where your degree is 0. So if we have the rational expression 7 over x plus 5, then the domain cannot include something that makes this denominator equal to 0. So we would set x plus 5 equal to 0, because we know that x plus 5 cannot equal 0, so you could go ahead and put that the bar through it if you wanted to remind yourself. So x plus 5 can't be equal to 0, which means x can't be equal to negative 5. So therefore we're going to exclude negative 5 from the domain. For 1b, let's say we have x over x squared minus 36. Okay, so this is a rational expression because of a polynomial and numerator and denominator. For domain, remember, though, we're only concerned with the denominator. We don't really care about this x up here. We only care about this denominator here. So we know that x squared minus 36 can't be equal to 0. So because this one, there's no other x terms, we can just isolate it. So we know that x squared can't be equal to 36. Taking the square root of both sides, you know that x can't be equal to positive or negative 6. So we're going to exclude positive or negative 6 from the domain. 1c. We have 7x over x squared minus 5x minus 14. So again, we don't really care about the numerator. We just know that this denominator, x squared minus 5x minus 14, can't be equal to 0. So figuring out the zeros of this one, first see if it factors. So two numbers that multiply to 14 and are going to subtract because this is negative to negative 5. Well, 2 minus 7 is going to give me negative 5. So I have a positive 2 minus 7. So we know that x can't be equal to negative 2 or a positive 7. If it's equal to either of these, this expression is going to be undefined.